Hello and welcome to Masterclass number 20. My name's Morag Gamble, the founder of the Permaculture Education Institute. Tonight's topic is all about marine permaculture, and I'm absolutely delighted to welcome to this Masterclass series Dr. Brian von Herzen. Brian is the founder of the Climate Foundation and is also the originator of this idea of marine permaculture, which, as we discuss, is very much part of the whole permaculture. It's kind of like a missing link. It's absolutely fantastic way to look at how we can restore planetary systems, to reboot ecological systems, to help feed people, help support local economic systems. I know that you're going to absolutely love this session. It was an absolute delight to interview Brian the other day. So before we dive in, I'd like to just let you know a little bit about Brian. So Brian originally studied physics and then moved into computer science and planetary science, firstly at Princeton and then at Caltech, and then across to Woods Hole in Massachusetts, where he was studying marine biology and also oceanography. His father was an oceanographer, and so as he says, you know, the ocean is in his blood. He absolutely loves it, and he has a complete passion to make a positive difference in this world and to address the current climate crisis and ecological crisis through this solution of marine permaculture. Now, I have pre-recorded this interview with Brian just because we're on other sides of the planet and we wanted to make sure that this worked and that we were both awake at the same time when this was taking place. However, I do want to let you know that Brian is currently present and waiting to talk with us, but as a chat. So as we're listening to the presentation and the conversations, you're very welcome to send in your chat questions and he will answer them directly and live. Now, I wanted to let you know too that for this session, there's normally around about 2,000 people who register to watch this program live. And if you're one of those people, welcome and thanks for being here. You can dive in and start chatting live as soon as you like. However, if you're watching this as a recording, our system doesn't allow those chats to be viewable. What I am going to do, though, is to download those and to make them accessible in another way so that you can see the question and answer. And if you do actually have questions that haven't got answered through that, still feel free to send those questions in. And I know that Brian would be very happy to answer those as well. So like all of the masterclasses, this is sponsored by the Permaculture Education Institute, and we offer an online Permaculture Educators Program, which is actually one of the programs that Brian is part of. So he is one of the founding members of the Permaculture Education Institute and a founding member of the Permaculture Educators Program. If you'd like to find more information about that, I've put the link beside at permacultureeducationinstitute.org. You can find out all about that program. I also offer lots of free permaculture education, free permaculture information through my YouTube and my blog, and also have an introductory course, which is the incredible edible gardening course, and that can be found at ourpermaculturelife.com. The other organisation that I wanted to let you know about is the Ethos Foundation, which is a registered charity which I run, and every single dollar that comes into that I send directly to communities in need that are looking for access to free permaculture education. So I'm particularly focused at the present moment in supporting women and young people, young farmers in East Africa. We just recently supported a permaculture design course there and a permaculture educators program, and also helping to set up a demonstration permaculture farm where people can come and learn. So I'm always accepting donations to the Ethos Foundation. I'm currently trying to raise funds for a number of young people to attend a permaculture design course in December. So whether you see this in December or any time, I'm always accepting donations, and they will always go directly to communities in need, and I can guarantee that. So ethosfoundation.org.au if you'd like to support or find out more information about that. So without anything else to say, I think now is the time that I will open up the conversation and the presentation from our very special guest tonight, Dr. Brian von Herzen. So welcome, Brian, to the masterclass series, and thank you so much for joining me here. It's this is masterclass number 20 in a series of topics that have been chosen by people who are participants in the Permaculture Educators Program and also people who sign in online. So these masterclass series go out to thousands of people around the world in the permaculture community. And because marine permaculture is and it's kind of like a new, I know it's not new for you, but it's a new concept that's come into the world of permaculture. I'm really happy that you've joined us here to give us kind of more of the background on how it works, why you're doing it. And I think maybe before, you're going to share some slides to explain how this all works and why. And I know we're going to get into that. But before we do, I thought it'd be really great just to hear a little bit from you about, what it is that inspired you to one, create this system that you do, and also to call it permaculture, marine permaculture. I know permaculture's, it can be applied to all different scales and concepts, and I'd never heard of it applied into the ocean before. And as soon as I did, I was absolutely fascinated. So, the inspiration and motivation, and that'd be great to hear about.
Well, thank you, Morag. It's a real pleasure to be here today and to have the chance to talk about marine permaculture and how we've come to it. I was really inspired by the story of permaculture, and it was, I think, poetic that by studying the marsupials in the rainforest of Tasmania, this notion of permaculture came to be. And what I love is that we're bringing it back to Tasmania, and that it's actually, I've had multiple people tell me, if the originators of permaculture had known what you're doing with kelp forests and marine permaculture, they would absolutely love it. Because I see permaculture, as I learn about it more and more, as a design philosophy. It's really about being in harmony with nature and ecology. And by understanding the multiple trophic levels of nature and equilibrium, we can sustainably harvest from nature while ensuring that nature can do her job of sustaining the planet. And I think it's that inspiration that really gets me up in the morning and ready to go and growing more kelp forests. So it's a real pleasure to be here because I continue to learn about permaculture, design, and philosophy. And my father was an oceanographer, so I grew up with the ocean. It's kind of my home turf. I've been called a sea otter or a dolphin at various times, and it's just kind of my element. We just came back from over a month doing sea trials in Puerto Rico, and we had the chance to really figure out how permaculture works in the Puerto Rican trench, test out the hardware, but also just to make sure everything's working and that it works around the world, and starting with the tropics and the subtropics and the red seaweeds that are there and our work in the Philippines, but extending also to the kelp forest from Tasmania to California. Mm-hmm. And those kelp forests are so magical because they are some of the largest and fastest growing organisms on the planet, and they're such a foundational species for the health of the marine ecosystems. And unfortunately, because of global warming, they've been decimated in the past decades, and there's a real political will to try to restore the kelp forests themselves and regenerate those ecosystem services in Tasmania. And now it's beginning to grow in California. And I like to say, today's Tasmania is tomorrow's California, because the dire need is there, and we've been very happy to be working with the University of Tasmania, with the Intrepid Foundation and other partners to really make sure that this works, and to ensure, I think, that Australia will have the first prototypical marine permaculture upwelling system on the planet, and we're really looking forward to enabling that in the new year. In the early 2000s, we had several expeditions across Greenland, and the first few, we saw Greenland melting. There were melt ponds that were caused by the temperature and the sunlight. And every time we crossed, it seemed like the melt lakes were doubling in size. Pretty soon they were 10 kilometers across and more than 100 feet deep, deep blue, and just getting bigger by the minute. And sure enough, by 2012, 97% of the surface of Greenland melted. And it was really that realization, even early on in the early 2000s, that made me realize that we needed to do something to halt this. And it ultimately needed to be a way to balance carbon in our seas and our soils, And it needed to be led by nature. It needed to be led by biology. And that was the inspiration that led me to first taking a sabbatical in Woods Hole and studying microplankton biogeochemistry, but then also looking to the soils and understanding what is it about carbon in the soil and soil microbial communities that can transform the earth from what I might call a killed NPK fertilizer traditional green revolution to a living biological understanding of the soil microbial communities that can rebuild carbon in our soils and really make it sustainable. And I would say from our carbon farming work in the States and around the world that biodiversity below the soil is equally as important as biodiversity above the soil. Mm-hmm. And that extends to the seas. There's a giant circle of, I'll call them nutrient value chains, that goes from seas to soils and back again. And there's an incredible mystery that happens, and that is we've been doing some early work with seaweed biostimulants, which are basically just liquid seaweed extracts that you can either apply to seeds or apply as a spray to the leaves of plants. And the present understanding is that there's something in the seaweed liquid that actually stimulates the plants to increase their budding and flowering. And so any food or fruit or vegetable that relies upon flowering is augmented. And I was amazed to learn that the wineries in California wouldn't really think of doing business without seaweed foliar biostimulants. Mm-hmm. And so this is an example of how the sea gives back to the soil. And then I think when it's done well, we minimize runoff going back to the sea. And that's essential for the kelp forest, because much of the California kelp forest was lost because of the turbidity of the ocean. And that refers to the murkiness of the soil. If you have runoff from your farms and your gardens, then it's going to go into the ocean, and that reduces visibility. The juvenile kelp plants have to grow from 25 meters deep all the way up to the surface. If the water is too murky, they don't get enough light to grow. And so the habitat is reduced. And we've seen this in kelp forests off California. We've seen it even in seagrasses in my home state of Massachusetts. And so having enough sunlight, enough nutrients in the right ratios are critical for these ecosystems. And so I think this is a way that our soils give back to the sea, and ideally with a permaculture that retains the soil and the nutrients on the land. And then conversely, and in a full circle, the seaweed ends up providing essential micronutrients and also these other plant regulators that go back to the plants. And I find that this circle is one of the best things I did. I had a chance a few years ago to spend some time at Esalen in California, and they have a large composting and organic farm and all the rest. And I felt like it was really funny because I went down to the ocean. I pulled up this big, long piece of bull kelp, which has got this huge, I mean, it's like, I don't know, it was more than 20 or 30 feet long. And I dragged it all the way up the cliff and brought it over to the compost pile. And they were telling me that no one had really thought about composting the seaweed along with it. But I'm sure somebody had done it in the past, but it felt great to actually make that circle and get it back into their farm.
What I'm hearing from you, that it is actually kind of completing that circle in terms of the whole systems approach, which is what permaculture is all about. And it feels something like this is a bit of the missing bit that we haven't seen. When we talk about earth care, we've been talking about land care, whereas we need to think about planetary care. And that's
exactly
the whole system. So my daughter wanted to ask you in particular about what are your hopes with marine permaculture. So this is my 13-year-old daughter. She wants to know what the big picture, because I know this is a big picture idea. If it succeeds the way that you imagine it to be, what do you see the impact to have?
We see the potential to save life in the ocean one kelp forest at a time. And that literally we've collapsed most of the fisheries on the planet, sadly. Half of the fish biomass has been extracted in the last 30 years, and 90% of the big fish are gone from the ocean. And with marine permaculture, we see the potential to regenerate the primary production from Tasmania to California and across the tropics, to create habitat for forage fish, the small vegetarian fish, and then to ultimately regenerate the schools of sardines, of anchovies, even of wild salmon, in a way that ultimately enables permaculture to transcend traditional aquaculture practices. We may be able to grow fish in the future with no nets, no fish feed, and no deep water moorings. And imagine that world. I mean, it's really bringing nature back to where she was pre-industrially. And so that's what really gets us up in the morning. I feel like Johnny Appleseed, and we've just entered the Ohio Valley, and we've got millions of kelp trees to plant, kelp forests. So it's very exciting from that perspective.
My son, the 11-year-old son, had a question as well, and his was about, he understands that there's some big picture, like some big systems that you're talking about, but are there also some small scale pictures? We've just come back from working with communities in Africa, for example. So local farmers in places like Africa or Indonesia, are they able to do this as well?
Yes, we are now have the support and funding from the Grantham Foundation to build a hectare scale marine permaculture in Philippines. And that will enable 250,000 seaweed farmers in the Philippines to sustain their livelihoods. So they've, in the previous decades, been able to grow seaweed commercially and provide it as food, actually, as well as feed and fertilizer to numerous markets. But in recent decades, the water's become too warm and the nutrient levels have become too low. And the net result is that the seaweed farmers are no longer able to make a sustainable living, and the seaweed communities are collapsing. So what this will be able to do is, by bringing irrigation to what otherwise would be dry cropping of seaweed, and that is cool water with higher nutrient levels from the deep, it restores the overturning circulation that nature started with. And in spite of global warming and climate disruption, we're able to get those nutrients and that cool water back to the seaweed. The seaweed then thrives. And that enables individual farmers and individual farming communities to regain their livelihoods, really. And if it works there in Philippines with 250,000 seaweed farmers, we have more than 2 million seaweed farmers in Indonesia that need the same services. In 2016, off Bali, I believe the island of Nusa Penida lost 60% of their production of seaweeds, and half of the seaweed farms were abandoned that year. And so some of it's been replaced with tourism there, but if you go further to more remote islands, they suffer the same consequences of marine heat waves. And what we need to do with marine permaculture is build climate resilience into each and every marine permaculture seaweed farm that we build. And we do that because, in a sense, we have a water conditioning system from the deep. Because we have a renewable source of cool water, we can ensure the temperature and the nutrient levels will be controllable even during marine heat waves in the years to come. So we're building climate resilience into the seas that way. And I think when we have diversity in soils or seas, marine biodiversity, the more diversity of species we have, I find that those ecosystems are more resilient. And when they're more resilient, they can resist, they can withstand the onslaught of marine heat waves and other heat waves and drought conditions much better than if they're monocropped. And so we see that as a foundational principle in the ocean as well as on land.
And so before we dive into your slides, I mean, you're not just talking about sort of trying to slow down climate change, or you're actually trying to talk about reversing.
Definitely.
Which is a big shift, which is quite an interesting concept, really, when we're thinking about the situation that we're in, and that the solutions that you're offering and the scale of it being a big picture idea, but something that's locally adapted all around the world, I think has huge implications. And I just find myself smiling a lot when I think about the work that you're doing, and just really thankful that you've brought this idea into the world and are sharing it so generously around the world.
Well, thank you. It's my pleasure to do this, and I feel as though it's really important. We've had multiple decades in the oceans of trying to do fewer bad things, and that's very important. But we also have to do more good things, and that to me is restoration and regeneration. And by recognizing that the kelp forests have a very important role in being one of the most productive ecosystems on the planet, by some measures even more productive than a tropical rainforest. Well, if Victoria and New South Wales and Tasmania's tropical forests, so to speak, are the kelp forests, then at least what we could do is help to restore and regenerate them to their former size and their former glory. And then beyond that, to understand and learn from nature. I feel as though, well, one of my teachers at Caltech was Professor Richard Feynman, and he loved to say that you don't understand a system until you've built it. And I've extended that to say, you don't fully understand an ecosystem until you've rebuilt it. And I feel as though that's one of the foundational principles of permaculture, and that is to understand an ecosystem well enough to understand the relationships between prey and predators, between herbivores and carnivores, and to create enough of a balance that you can have enough of the ecosystem intact to be able to sustain the ecosystem and also sustainably harvest. And I think that balance is something that we should apply to the ocean and to the ecosystems like the kelp forest. And if we get it right, we should have a thriving kelp forest that is able to sustain itself. Just earlier this year, I saw a film called The Biggest Little Farm, and I got to meet. There was a question and answer after the film with the farmer who had created the film, and it was wonderful because what I loved about what he had to say is that I think he was asked something about the restoring force on the planet, or how he felt that we could get back to a successful planet. He said, well, the strongest force that we have on this planet is our community consciousness. And that community consciousness of having the will to regenerate a healthy ecosystem, a healthy planet, a healthy climate, is our consciousness of understanding how the ecosystems work and our will to restore it on land and in the sea. And I felt that was so inspiring. And then a few days later, I ran into some permaculturists in Santa Barbara who said, we want to create a new kind of permaculture on the coast in Santa Barbara County. And we have the land part figured out pretty well. And we want to create a kelp permaculture offshore alongside it. And I thought that was so apt because they've done studies showing that the micronutrient levels of our food has dropped by a factor of 2 or more. And we've lost most of the micronutrients in soils that are depleted. And yet seaweeds have every element in nature. And when you put seaweed back on the soil in the appropriate amounts, you're really restoring those micronutrients. So that's another case where you have the full circle taking place. And I just felt that was really important. Go ahead.
Yeah, I was just going to say, and also a different type of food as well. So I can imagine a whole new type of, food products coming out of marine permacultures, which is going to have an enormous impact on our health and well-being as well.
I have to share with you that just a couple of weeks ago, we ordered some seaweed salsa from Alaska, and it was some of the best salsa I've ever had. It's kind of, a spicy Southwest Mexican kind of a style. And we had so much fun with that. And when I was in Byron Bay earlier this year, we had the chance to try some seaweed sauerkrauts as well. So we're experimenting with all of these little additions. And the sauerkrauts are just a little bit seaweed. But what I loved about the salsa is it was the first ingredient was kelp. And it tasted wonderful. So we've got to come up with these recipes and find these combinations of seasoned soils that can produce wonderful new foods.
Fantastic. I can't wait. Should we dive into your presentation, and we can talk more at the end as well?
Certainly, I'll look forward to that. So I'm Brian von Herzen from the Climate Foundation, and we're going to talk today about marine permaculture, regenerating ecosystems from soils to the seas. They have an essential connection to each other, and I look forward to exploring this with you today. At the Climate Foundation, we focus on 3 fundamental aspects, and that is food security on land and in the sea, ecosystem survival during marine heat waves, during climate disruption, droughts, and heat waves, and finally, the carbon balance that we can achieve in soils, where every person's garden can become a carbon sink, and in the seas, where each kelp forest and each seaweed forest can in fact fix carbon and help to restore ecosystems. So that's the setting. Let's talk about the problem to some extent. I was amazed to learn that 93% of global warming ends up in the sea, and that results in vastly warmer seas and critical ecosystems that are, quite frankly, the canaries in the coal mine. Between the coral reefs and the seaweed forests, these are the ecosystems that are on the front lines of climate disruption, and they're the ones that often bear the brunt of the most severe heat waves that we encounter. Um, Prof- Professor Charlie Varon in 2008 gave a lecture in the United Kingdom on the mass extinctions and how they were preceded by coral um, bleaching and coral reef ecosystem loss that occurred at the cusp of each of these extinctions. And we're seeing, of course, some coral bleaching again now. And the concern is whether we're on the verge of this sixth mass extinction at the hand of man, and whether we could, in fact, prevent that from happening at some level. And that's why the work that we're looking at today is so critical. Just in the last couple of years, we've realized that it started with asphyxia in the oceans. And so the oxygen level and the primary production in the oceans produces most of the oxygen we breathe today. And it also is what keeps the oceans alive. And that's what we have to try to address. And if the oceans become stratified due to the warm temperatures, then the lack of overturning circulation can cause a lot of these extinctions to take place. In fact, 96% of marine species and 70% of land vertebrates went extinct during this time. And Vischer made a conclusion that nearly all of the world's trees died en masse during one of these events, where one of the repercussions of the seas going anoxic was that it had repercussions on the atmosphere and on land. And so this was a very dire situation. It's something the Earth system has done before, and it's something that we should try as much as we can to avert. And I believe that fundamentally comes from ensuring that nature's ecosystems can continue to thrive. So the problem is now that, well, the UN special report this year has indicated that 1 million species are threatened, and that's more than 10% of all the species on the planet. So I view that as a very concerning aspect, and we have to be able to address it by sustaining ecosystems. Off the coast of Tasmania, this time series shows the marine heat waves of the East Australia Current that have been descending upon Tasmania over the past decade. And this has contributed to the water being too warm and the nutrient levels being too low for the Tasmanian kelp forest. And so we're working with the University of Tasmania to try to address this and develop a marine permaculture system that can ensure the proper temperatures and nutrients for the seaweeds to thrive, as well as selecting warm adapted genotypes that are in Tasmania that can in fact do perhaps a better job of warm tolerance at the same time that we try to address the nurture problems of getting proper temperature and proper nutrient levels. Professor Johnson documented the loss of kelp forest in Tasmania over the past 4 decades. And in eastern Tasmania, they went from being able to sustainably harvest the forest in the 1970s to not having enough forest to even sustain the wild ecosystems in this decade. So it's a severe situation that we need to try to address, and it's one that we are beginning to address. And in Western Australia, we've seen similar problems. There used to be a Colonia kelp forest, shown in this figure A here on the top left, that extended over 1,000 square kilometers north of Perth. And unfortunately, that during the marine heat waves of 2011, that was converted to turf, and that turf is much lower productivity and much lower habitat for fish. And so it came all at once, really just in 1 year, but it's bistable. And so that means it's stable as a kelp forest, and it's stable in just turf. And unfortunately, until we address some of the root causes of the problem, we don't expect that situation to flip back anytime soon, unless we can provide the right substrate, the right temperature and nutrients to enable this kelp forest to grow either offshore or back where it was originally. And we hope to do some of both. Off of Tasmania, this kelp forest habitat's collapsed. 95% of the Macrocystis kelp forest is gone. And yet we have a program that we've now been able to raise support for that will enable us to build first a marine permaculture offshore, and that'll be out during the summer months. And when it goes and we get to put it back into the bays and harbors in the fall for protection, it can actually sporulate and reseed the Macrocystis in local nearby bays and harbors. And we think that can be a key to restoration of the kelp forest that once was, as well as regeneration of the kelp forest ecosystem services offshore and sustainable harvesting offshore on our cultivated marine permaculture systems. And of course, these kelp forests are the home of the leafy sea dragon off of South Australia and the weedy sea dragon off of Tasmania. And I view these as iconic species. It's so wonderful to have sea dragons, in our world, and yet this is critical habitat for those species. And I think, I believe it's the one of the state symbols of South Australia, if I recall correctly. And it's so important that these iconic species can help galvanize the motivation to ensure these ecosystems remain alive for centuries to come so that we can retain the species diversity that is so important from Australia to California and around the world. And I think Greta has really showcased the need that we have to keep these ecosystems alive. It really is their future, and I'm dedicated to the principle that we need to ensure that we leave the planet with as much species biodiversity as we arrived on the planet. And I think we must do as much as we can to ensure the species biodiversity remains during our watch. And I think that's all about ensuring diverse ecosystems in soils and also in the seas, that having as much biodiversity above the soil as below the soil is essential to having a healthy terrestrial climate. And similarly, having that biodiversity beneath the waves is absolutely essential to ensuring that we can keep our ecosystems going. And so we start with the very base of that ecosystem and work up from there. The school strikes have increased in number. I was heartened to learn that over 7 million people struck in September around the world during Climate Week. And these Fridays for the Future are essential to, I think, raise an awareness that it's important for us to build the grassroots political will to ensure that our leaders understand how important this is to really sustain our planet with a healthy climate. So let's talk about approaches and solutions. We started with the shores off of California, where unfortunately over the past 150 years, we've seen a similar demise of kelp. There used to be a river of kelp shown on the right-hand side that extended from Point Concepcion in Central California all the way to the Mexican border, and it was nearly continuous. But with farming in the early 1900s, the murkiness of the water, the turbidity, increased to the point where there's just a few little bits of kelp left off of the Santa Barbara shoreline, and a lot of it's been due to runoff that occurs from farms and other forms of industrialization. And so we asked the question, what if we could restore these seaweed forests and restore livelihoods and ecosystems? What would it take to do this? And the vision that we have is the healthy kelp forest that's teeming with abundant life in terms of forage fish, game fish, apex predators, marine mammals, and seabirds. This is just kind of the epitome of the diversity that we see and still see in a few isolated places off the shores of eastern Tasmania, all the way to New Zealand and even California. So we know what these ecosystems can do in the ocean as well as on land. And the question is, what do we have to do environmentally to be able to restore and regenerate these ecosystems? Well, the potential is enormous. As I mentioned, the algae beds and reefs are very productive. This chart on the left is all these different ecosystems and the percentage of the Earth's surface. In the middle, it's the average net primary production, which is how many grams of carbon a particular ecosystem will fix in a particular year. And a tropical rainforest can fix over 2,000 grams of carbon every square meter every year. And that's a very high number. And we think of the tropical rainforest as being one of the key places where we can have life be able to fix a lot of carbon and keep our Earth in balance. What surprised me is that kelp forests, algae beds, and reefs have even higher amount of carbon fixation per square meter per year, 2,500. So that's 15% more carbon fixation according to this reference. And what's intriguing to me is that if we can learn how to grow kelp forests offshore as well as on the shoreline, then we could take this very large number, which is the open ocean, 2/3 of the Earth's surface, and multiply it by this very large number, and that is the average net primary production of a kelp forest. And we can literally reseed the existing kelp forest, grow more kelp forests offshore, and do a lot to generate enough food for people, enough food for the ecosystems, and fix enough carbon to begin to draw down the excess carbon that's in the atmosphere. So we view this as a real heartening insight, and it's one of the original motivations that we've had for working in kelp forests and marine permaculture in particular. Now, before global warming, we had natural upwelling systems so that if you get, let's say, an offshore wind in Australia, it will bring upwelling to the surface. In fact, I was in Byron last summer, and I think we had a bit of a north wind, and north winds are normally warm in Australia, but this north wind, it runs along the shoreline and it turns left because that's the Coriolis force of the earth. And as it turns left, it draws the seawater away from the shore, and the water temperature drops by 5 degrees or more. And that's the natural upwelling process when it's working well. And so it brings up cool, deep water naturally. The problem is when you have global warming, the layer of warm water, shown in light blue here, is deeper and it's warmer, and it creates an energy barrier that prevents as much upwelling to occur. And if you know from soils that you need to have enough nitrate, enough phosphate, enough micronutrients to grow plants, the same is true for marine plants and algae. And that is, we need to have enough upwelling to have the nitrate and phosphate and other micronutrients available. And in global warming scenario, this is a stratified ocean, which is what we believe caused the Permian extinction. If you have a stratified ocean, the nutrients stay down on the bottom, you don't get them up to the surface, and you don't get the primary production. And without the primary production, the ecosystems collapse. So that inspired the notion of marine permaculture, which is that we have to have a hose that goes deep enough below the thermocline to bring up the deep, cold, nutrient-rich water. And we use solar energy in the tropics and wave energy in the temperate latitudes like Tasmania to irrigate up to a square kilometer of kelp forest and seaweed farms and enable them to have the proper nutrient levels and the proper temperatures that they experience pre-industrially. So that's the inspiration that we've had behind marine permaculture. And this is what it looks like at a 100-hectare scale in the Pacific Ocean, where we would have a kelp forest that can be habitat for forage fish and could be at a depth of 25 meters in the case of kelp forest, and shallower for some red seaweeds, and be able to grow all the way to the surface. And so that's the notion that we have, and we start at a small scale of Tasmania, and then eventually get to hectare scale and even kilometer scale ultimately with this technology. So to give you a bit of a technology roadmap as to what we've been doing over the past dozen years, we started back in 2008 with the University of Hawaii, and we confirmed that upwelling would grow algae in the Pacific Ocean, and that worked very well. Then in phase 2, we've been using trough-based systems to show that we could actually upwell water. It was with the Blue Economy Challenge and the Department of Foreign Affairs and Trade in Australia, and we were able to get this working in Indonesia and show that we could in fact grow seaweeds in the troughs. Then in phase 3, we're being supported by the Intrepid Foundation, the 2040 effort, and the work that we're doing with Tasmania, as well as work we're doing with foundations in the United States to develop a hectare scale marine permaculture. And here the concept is very much to be able to grow the kelp up from the bottom, irrigate the seaweed farm with enough cool water and nutrients from the deep, and ensure sustainable growth of this farm at a hectare scale. And we anticipate seasonally deploying it off Tasmania in the spring and summertime, and in the fall bringing it into the bays and some of the more protected areas where these kelp forests can actually sporulate, and they can distribute their gametophytes and sporophytes to the shoreline and actually help to reseed some warm adapted kelps that are locally developed in those areas. And that gives us some hope that even with the higher temperatures, some of these warm adapted kelps can continue to take hold and actually restore some of the kelp forest. The harvesting we would do offshore off the marine permacultures themselves, and then ultimately, once this is successful, we anticipate being able to go to 100 hectares, which is a larger system. But the hectare system may be very important for the subsistence farmer because that's about the right size for the seaweed farms, and we anticipate developing those in Philippines and Indonesia, and that will be very important for subsistence farmers around the world. In addition, we should be able to grow larger systems offshore, ultimately in the deep ocean. And I like to say that between my home here in Woods Hole and Australia, we have 100 million square kilometers of accessible area that is amenable to marine permaculture. So by going further offshore, we can effectively build new farmland, if you will. Ultimately, we're anticipating at a cost of less than $1 per square meter, which ends up being the price of farmland in the UK. And so it's very intriguing that we can, in fact, help create new productive kelp forests that are affordable and practical and scalable. And that's what we anticipate for phase 4. Now, in phase 1, we demonstrated with simple wave-driven upwelling pumps that we could, in fact, upwell the water and grow the algae. And in fact, we had a whale shark take up residence around the marine permaculture, the system. 2 weeks after the system had finished operating, the whale shark was still circling and eating the plankton that had been created. In phase 2, we're helping the subsistence farmers in Indonesia and Philippines, and this was to grow some of the red seaweeds that are commercially harvested today and ensure that we could, in fact, get this working well. And so we actually deployed a system with an upwelling hose and was able to show the superior growth of red seaweeds with irrigation from deep water. This is what some of the red seaweeds look like. And of course, it ends up creating habitat for forage fish in addition to the main crop of the seaweed itself. And so we see that as a key opportunity. Now in phase 3 in the Philippines, we're going to be accelerating this development and doing it at a hectare scale. And so we're looking forward to really increasing their ability to grow more of the year, to grow seaweeds, because right now they're limited to around 5 months a year. And potentially they could be growing 12 months a year as they used to in the past. But they need to have the conditions. Well, it's like the difference between dry cropping on land and irrigation. We expect to be able to potentially double the production of these subsistence seaweed farmers. Then in phase 4, we go to 100 hectares and further offshore, and it may require some larger fishing boats to access it. But we anticipate still that island nations and islands will be able to harvest multiple large marine permacultures and be able to develop a sustainable livelihood, really, in both seaweed and fish, because we're expecting with the fish habitat to be able to grow lots of fish in the future. In fact, I'm happy to report that just in the last few weeks, one of our marine permacultures off of Philippines has had sardines collecting underneath it and growing. And we've seen a lot of these fish eating some of the seaweed, which is great. It's kind of a great sign that not only is it habitat, but also food for these forage fish. And we've started to get sardine fishermen coming and fishing for some of the sardines at night along the side of the marine permaculture. So we're very encouraged by the already, before we anticipated this, not only finding the sardines taking up residence around these permacultures and the sardine fishermen starting to harvest them. So we find that to be very encouraging. This is a picture of the 100 million square kilometers of accessible area between my own home state of California and Australia. And it's truly enormous. I mean, we should have called this planet ocean because it's so vast. And yet 99% of this area is ocean desert today. And the opportunity to regenerate the ecosystem services of the kelp forest that we've lost off of Australia and California, and then to further extend those ecosystems offshore so that we can restore productivity and ensure that we can regenerate fisheries and ultimately have enough food for humans on the planet, enough food for the ecosystems, and enough carbon balance so that we can get our natural climate back on track to a healthy climate. Those are the main objectives we have with marine permaculture, and I think this view of the Earth sums it up in terms of the potential magnitude that we have for this particular approach. And I always love this picture because it shows the sardines and the small forage fish living in the kelp forest. And it ends up being thousands of tons of seaweed that can be harvested each year per square kilometer. Thousands, and that's 1 ton of seaweed is about 1 ton of carbon dioxide within about 10% or so. And so that means that potentially, as we develop our capability to grow more and more seaweed, we'll be able to fix more and more carbon. And what we don't use for food, feed, and fertilizer, we can actually sink into the middle and deep ocean it takes about 2 days for the seaweed to sink down to 1,000 meters depth. And at that depth, our physical oceanographers have said that it takes 100 to 4,000 years for the median time for that water to outcrop again at the surface, which means that the carbon is effectively stored in the deep ocean for centuries, and that provides a true carbon sink that the United Nations has provided carbon credits for carbon sinks that exceed 100 years. In addition to several thousand tons of seaweed, we can expect several hundred tons of fish based on the trophic levels and the fish relationship to the seaweed itself. And so we're seeing the opportunity to sustainably harvest fish as well as seaweed from the kelp forest in years to come. In fact, there are many applications. Seaweed is already a more than $10 billion market in Asia for food and feed and fertilizer, but it's going to more than double in the next 5 years. And with these applications, as well as fish, biofuel, fiber, and I think in Tasmania, there are even nutraceutical companies that are developing really amazing superfood applications for seaweed and seaweed extracts that have transformational health properties as well. So we see this as a very important way of regenerating our economies at the same time that we're regenerating our ecosystems. And you may have heard about how the cattle feed is one of the key aspects of how we can reduce methane. And I was very intrigued by the original discovery of this because it ended up being in Nova Scotia that they discovered the cows on the beach seemed to be healthier than the cows that were across the road on the farm. So I think that's a really essential thing to consider, and that evolved into a study of what effects it was having, and it turned out the seaweed is something that the cows seek out. I think the deer in New Zealand have been found on the beach eating seaweed at night as well. And what I love is that these natural ruminant livestock and these natural ruminant animals in the wild have been going and eating seaweed on the beach. And so I think the idea of having a seaweed salt lick for cattle and dairy cows in the future is going to be very important for Australia and the United States and everywhere where dairy is desired. And I think it's the fundamental aspect of having carbon negative dairy and cheese in the future that are important products that people have relied upon, but being able to reduce their carbon intensity and in fact make them part of the drawdown solution is going to be really essential. And along those lines, I want to say that for dairy cows and even for cattle and livestock, the key to carbon negative dairy and carbon negative cattle is 1 part seaweed and 2 parts soil management. So this is where our permaculture in seas and soils come together, because we have to do both in order to make a technology that historically has been emitting a lot of greenhouse gases into a carbon negative technology or climate positive technology. It requires input from the sea in the form of seaweed supplements. It also requires rotational grazing practices that can enable us to build carbon into our soils. And by doing rotational grazing and seaweed together, we can make dairy carbon negative where it was carbon positive in the past. And so I think that's the kind of approach that we need to do, where we're using both of our hands, if you will, once by land and the second by the sea, to actually enable these, transform our civilization to one that's going to be sustainable from an environmental standpoint. I'll also mention briefly that the diets that we have been doing, certainly in the West, there's a lot of sugars and saturated fats and not so much fiber. And that's resulted in the United States, at least, in having a declining microbiome. And, you know, the microbiome in the soil is not that dissimilar to the microbiomes that we have in our gut and our own systems. And that diversity in the microbiome is pretty important for health and whatnot. And from a health standpoint as well, I note that the United States and several other countries have very low rates of EPA and DHA. These are nutrients that are present in seaweed, in microalgae, and in small fish. And the small fish get it from the seaweed. And these it's turned out these long chain omega-3 fatty acids are very important for cognitive health span. And a significant fraction of the population, more than a third of the population with Alzheimer's genes, need to really move to more omega-3 based diets. And that's often a coastal diet. Seaweed, small fish, vegetables, and yams are historically what's been cited, and moving away from grains, which are omega-6 high. And so this is some of the important trends that I think we need to think about from a nutritional health standpoint, as well as from a climate standpoint. I'm also going to touch on a few health aspects where they found that seaweed had transformational effects from a number of major issues, including cancer. Here's a study on breast cancer, where in a mouse model, they found they were able to induce tumors with a mouse model in as little as 12 weeks. And the black squares represent the same mice with the addition of a seaweed supplement, and the seaweed supplement had a transformational effect with more than a factor of 10 fewer tumors, even out at 24 weeks, no tumor incidence. And the same happened in this right experiment as well, and in terms of the number of tumors. And so that to me was really transformational, that seaweed, a small amount of seaweed in the daily diet could have such a big effect on cancer. In addition, there have been fairly significant effects observed and reported with Alzheimer's. Some European studies from this year have indicated that, if I recall the figures correctly, they had Alzheimer's mice that they were near the end of their lives, and they couldn't remember how to get through a maze. And when they added a little bit of seaweed to their diet, they were able to start remembering how to get through the maze again. So that was a pretty transformational effect on Alzheimer's as well. And there's multiple references that have cited to reduced loads and improved short-term memory with seaweed in the daily diet as well. And so this is the cow walking on the beach metaphor. I think in Nova Scotia, there was a farmer that had a cow whose farm, it had a farm, and they had dairy cows. There was a road splitting the farm, and half of the farm was by the beach and half of the farm was on the other side of the road. And so the cows that were by the beach seemed to be healthier and heavier. And the farmer noticed after a while that they were actually eating seaweed down on the beach. And so it was very interesting to compare the set of cows that did have access to the seaweed on the beach and those that did not. And that became the basis for really exploring how cows could have their diets transformed and be a lot healthier with seaweed as part of their diet. I also want to touch on the potential for marine permaculture to address coral bleaching. We've seen dire effects of coral bleaching on the Great Barrier Reef, and we started 10 years ago to say, well, if we were able to cool off the reef by even a half a degree Celsius with marine permaculture, growing seaweed and having the cool water upwelled, what effect could we do? And so we found this place in American Samoa where it bleached every year naturally, and then we cooled off that water by half a degree Celsius, and we were amazed to see that we thought it might take 2 or 3 months to see a difference, but in less than 24 hours of treatment, this area of coral returned to color dramatically. And when we turned off the hose, even for 2 weeks later, we still had the coral retaining color. And so that was a really huge result, and we hope to get permission from the Great Barrier Reef Marine Park Authority to do a test in the Great Barrier Reef in the coming year or two, and see if we can in fact grow seaweed and help restore the coral reefs at the same time. Similarly, there have been many problems with salmon aquaculture in the past, and we've been getting some help from some of the salmon aquaculture companies to have permission to grow the seaweed nearby there. But at the same time, it reduces the nitrate loading because the seaweed absorbs the nitrate that's put off by the fish pens. And so we think that there's a way to have a multi-trophic permaculture that would effectively include seaweed as well as fish, and ultimately address a lot of the problems that have been occurring in the salmon aquaculture industry. And so in Norway, they had some fish losses, and by growing macroalgae, we could in fact improve the oxygen levels and reduce the microalgae that would grow in these environments. Finally, I do want to mention, because some of our viewers may be landlocked, that there are a freshwater version of marine permaculture that I think is very significant. That I was amazed to learn that this small little aquatic fern called Azolla actually grew prolifically during the last tens of millions of years. In fact, 50 million years ago, each summer, Azolla would grow across the North Pole, across the Arctic Ocean, and cover 1 million square kilometers of area in a single summer. Then at the end of the summer, the sunlight would fade and the plants would die and they would sink into the anoxic Arctic Ocean and lay down most of the oil that's in the Arctic today. So it turns out most of the oil in the Arctic comes from the small aquatic fern called Azolla. And it turns out that Azolla and duckweed exist already in the United States and in Australia. And it grows in some of the waterways and whatnot, especially it can soak up extra nutrients, extra nitrate and extra phosphate. And so if you have excess nutrients in your waterways and irrigation canals and rivers, Azolla could be a very good way of absorbing those extra nutrients. And the key is to be able to harvest it as soon as it's grown and before it piles up. And it turns out to make a very good feed supplement. I've seen chickens eating it and poultry and other livestock. And it turns out to be a very healthy feed supplement when provided fresh because it has a little cyanobacterium in it called Anabena that actually produces EPA and DHA. And so this is one of the few freshwater vegetarian forms of long-chain omega-3 fatty acids that's essential for cognitive health span. And so whether we get it straight from eating Azolla on our salads, or if you feed this Azolla to chickens, you'll get omega-3 eggs. And so it's a great way to boost the omega-3s that are on your local farm and absorb all the extra nutrients that can cause problems for waterways, rivers, and even coral reefs. So we see Azolla as a great sustainable approach as long as we can harvest it in a timely way and keep feeding it to our livestock and adding it as a little garnish to our salads. So this is some of the team. We have over 24 people helping us around the world in Australia, in Tasmania, in Europe, and the United States and the Americas. And we're looking forward to building our team, I would say building our community of permaculturists and marine permaculturists around the world and really extending the philosophy and the principles of permaculture to our seas as well as our soils. And I look forward to hearing from many of you and talking about how to get involved and how to really participate in projects that can start out small, but ultimately we hope to build a very sustainable livelihood for many people as we grow the principles of marine permaculture and develop kelp forests and seaweed farms around the world. We're very happy to be part of the drawdown 100 ways of, let's say, regenerating life in seas and soils and drawing down enough carbon to sustain a healthy climate. And that includes marine permaculture and the cows on the beach. We're also very happy to be part of the 2040 team and the impact team that's looking at how can we provide sustainable solutions for the planet. And they've been instrumental in helping us with the Intrepid Foundation in raising enough funds to test out the marine permaculture principles first in Tasmania, and later we hope across Australia, the Pacific Ocean, and the rest of the tropical and subtropical and temperate world. So with that, I will leave you with my beautiful picture of a weedy sea dragon, where I hope we'll be able to regenerate this kelp forest habitat for this and thousands of other species that depend on the kelp forest and on the coral reefs for their sustenance. It's estimated that 1/4 of all marine species spend some part of their life cycle on the coral reefs, and I think a similar number may be true for kelp forests as well. And by regenerating our natural kelp forests, I think we can go a long way to ensuring sustained biodiversity on the planet, ensuring that we leave this planet with as many species as we arrived. And with that, I would love to answer questions, Morag, and talk more about marine permaculture principles.
Thank you so much, Brian. And there was just so much in there that fits beautifully with how I've understood permaculture for the last 25 years and expanded exponentially. I actually think that as a result of the work that you're doing with marine permaculture, we need to completely update the permaculture design course curriculum to weave in marine permaculture. I think that's kind of an essential shift that we need to grow and evolve with this. There was a couple of questions that I had while we wait for some questions to come in from people who will be listening to this live. So one of the things that I wanted to ask you about, I can see all the enormous benefits, but I'm wondering what challenges are you facing in actually rolling this out, or whether you see there's any challenges that you might face ecologically in installing these type of systems?
Well, the nature, I would say the ocean is a harsh mistress, and in some ways we have to develop systems that are going to be very resilient. we're happy that there's been a lot of technology development by the aquaculture companies to develop systems that can withstand 11-meter waves in Storm Bay off of Tasmania and come out successfully. And so we need to learn those lessons. And effectively, by adopting similar practices and materials, we can find what is really sustainable at a hectare scale for a subsistence farmer, and what could be sustainable at a larger scale if we need to generate more food and ecosystem services for larger populations and for the larger questions of being able to actually draw down enough carbon on our planet. So I think we need to move one step at a time. Our systems right now are this next quarter, we're going to be going to Philippines and actually confirming the biological response of these seaweeds to the deep water irrigation. Once that happens, and we plan on doing that in Tasmania as well in the coming months, with our Philippines kelp seaweed farm, we anticipate being able to validate on a small scale that it works properly. And once that does, then starting next year, we'll be able to grow a 1 hectare farm, which will be about the right size for the seaweed farmers. They normally farm 1 hectare at a time. Similarly, down in Tasmania, initially we're working closely with the fish aquaculture pens where there's higher nutrient levels, and that could provide some more thermal tolerance. But our next step in phase 2 is going to be to go offshore in Tasmania and be able to grow 100 square meters of kelp forest using upwelled water. So that'll be a challenge, and the challenge is that in the wintertime, the seas can exceed 10 meters, which is really enormous waves. And so we're going to start out with the spring and summer offshore, and those are the months where you're getting the highest temperatures and some of the lowest nutrient levels, and that's when the kelp forest is under the most stress. And so that's when we need to provide the irrigation in the deep water. And then because the system is on a submerged platform, we can tow that platform back into the bay in the fall. And I've been told by our colleagues at the University of Tasmania that the kelp forest sporulates then. And so a lot of the gametophytes are spread in the fall. And so what better time than when we've towed it back in and protected it from the waves, it can also reseed the kelp forests all around the bays of eastern Tasmania. So we're thinking that's going to be a really great chance for doing restoration work as well as regeneration. So this will be an interesting thing for us to test. It's unusual to have a forest that's portable, but in this case, we should be able to do that. And we'll get it working at 100 square meters and then anticipate a hectare scale forest down the line, which we'll have to build the capital for. The first ones are expensive. And today, even if we're doing 100 hectares, it probably will cost us $10 a square meter in materials to get that running. But we have a roadmap to reducing the cost to below $1 per square meter. And what's intriguing about that from a capital cost standpoint is that someone pointed out to me just today, he said, the price of farmland in the UK is above $1 a square meter. So what you're doing is you're actually creating new farmland. You're creating new, and the price is less than the price that it costs to buy existing farmland. And so at that point, there's a shift. And the shift is that we can actually, we can develop more production. We can actually address the problems that we've had in the past. And the parts of the ocean that we're looking at offshore are, quite frankly, aquatic deserts. They're blue water, but especially with the warming, the productivity has been dropping. And this is a great way to restore that productivity. And we use nature as our guide. The natural kelp forest is really the guide to how, we get it right when the ecosystem is working well and we have a sustainable and a sustainable ecosystem running. And so nature's our guide in this case. Go ahead.
And I'm also fascinated by what you were saying too about how it can help to restore coral reefs, because here in Australia, obviously the Great Barrier Reef, the situation there is of great concern. And so the opportunity to do restoration work in places like the Great Barrier Reef and through all the coral reefs all throughout the areas above Australia too, which I know are really struggling, and that has an enormous benefit, which I think is absolutely fantastic. I had a question about so all of those oceans in the middle about creating new land. I mean, currently it's the global commons. So who do you ask to start creating farmland in the middle? How does that actually work?
Well, in the States, traditionally, it requires 17 state and federal agencies and more than a decade to get a permit to grow even a a small hectare of kelp forest
Yes.
near shore. And that's partly because the shoreline is so contentious. So we rely instead on 500 years of Admiralty law, which says that you can build an ocean vessel, call it an ark, and you can sail the seven seas, and you have the right to safe navigation. And so if we simply follow the rules for building an ocean vessel and set to sea and grow our systems, we can nomadically, if you will, grow our kelp forest just fine. And how we have 500 years of Admiralty law. All we have to do is register with the Coast Guard and the local authorities and fly the flag. And I think you need a life jacket for every soul on board, which may be 0 or 1 in this case.
So this is an interesting a nomadic system. I think that's kind of absolutely fascinating. The other thing, oh, sorry, you were going to say something?
Well, there are several, I would say, civilizations of people who are fishermen and are nomadic. Some of them live between Indonesia and the Philippines. Mm-hmm. And traditionally, they have not had the rights of people who stayed in one place because they're nomadic. And as we know, we have a long history that nomadic peoples are marginalized. And this really breathes new life into a nomadic lifestyle that, quite frankly, is much easier to permit than one that tries to. The real estate model, quite frankly, doesn't work very well in the oceans. So I like to say that ownership's way overrated, and this is really all about nature. And if we sail the seven seas with our marine vessels that can regenerate life on the planet,
it's really
and we do it locally and regionally.
I mean, the whole idea about, like you're saying, ownership of land and also the fact that, most of the land that's available now is taken up, and nomadic cultures can't really exist anymore anyway.
Exactly.
It's a really interesting concept. I also wanted to pick up a little bit on the Azolla idea. That's something that I've been working with here in Crystal Waters because we have some lakes. And that was the other question that my 11-year-old asked: can I do marine permaculture here at Crystal Waters? And exactly the Azolla. So we go down to the lakes regularly and we harvest the Azolla before it sinks and collect it. And actually, some of the sort of the nice looking bits we have been using as food, and we do, as we say, feed it to the animals. But I've noticed too that very rapidly it turns into the most amazing compost, and just goes straight into the soil underneath the mulch. And it's a fantastic way to reboot the life in the soil. So this cycle that I've been creating with that has been magnificent. So this, again, this sort of connection between the water systems and the land systems, we have to really focus on a lot more with permaculture. And
I agree. And I think, I'm sorry. I think there's an opportunity with the rivers to draw down the nutrient levels even further than they have been. And if we had a sustainable system that would insert the right level of Azolla upstream in the rivers, and it would grow as it goes downstream and be harvested at the mouth of the rivers, then you could bring the nutrient levels down as low as you needed to. And it would be quite a sustainable operation that could really help with a lot of livestock and food feed and fertilizer, as you mentioned. So I think there's enormous potential.
It does, but unfortunately it's it's declared as a weed.
I know.
Because it's, chokes up. So it's really an issue about management, isn't it? So
exactly.
Identifying it as a resource, as the amazing benefit that it does bring in so many different ways, rather than going, okay, it grows so rapidly, therefore it's a problem. We need to shift the thinking on that.
Definitely. Well, at some level, there are no weeds in permaculture. It's really about understanding what grows well and the fact that it doubles in 3 days, as long as we have a sustainable harvest plan. That's really the challenge and the opportunity. Yes. So, I think we need to turn what people view as waste into resources, and they're incredibly valuable. And I'm so glad to hear that you have them on salads. I'm looking forward to trying them myself.
Yeah, and I guess that's too, the whole thing around seaweed, it's called a weed too, which is just phenomenally out of...
on a call earlier today, we had someone call it sea vegetables, and, I think sea greens. All of those, I think, are something we need to move towards. Yeah,
absolutely. I think it's requiring a massive shift, and I love this idea too, that what you're doing out in the deep water and by the mobile systems, that you're actually helping to reseed and to regenerate kelp systems all around where they were before. Like that was amazing to see off the coast of Santa Barbara how much, and how much loss. I mean, I think this is something that we don't realize, that the oceans are really being a massive buffer in terms of taking in the heat, and all of the different impacts that humanity is having are actually being absorbed by the oceans and having massive impact. I mean, what was that, 94%? I wrote it down somewhere.
93.
93% of loss. That's phenomenal.
It is a huge factor, and I think there's something we call shifting baselines, and that is no one's alive today that was living in the 1840s, and so there's no living memory of the kelp forest that was off the coast of Santa Barbara, and yet that is the transformation that's happened in just less than 2 centuries, and so we need to have that memory. I pulled these maps up from the U.S. Geological Survey from 1848 and 1853, and it was right in the maps. It's like, and yet people have no living memory of those kelp forests that once were.
But you keep saying that there's been, even in the last 40 years, there's been a massive drop off the coast. Where was that again? Was that Western Australia, I think you were talking about?
Oh, yes, in 2011, but eastern Tasmania, since the 1960s and 70s, they were commercially harvesting, and the harvesting wasn't that strong. It wasn't wiping out the forest by any means. It's more like mowing the grass, because they just mow the top meter, and the remaining 20 meters grows up from the deep. So that continued, and I don't attribute the loss to the harvesting at all. But they went from so much kelp that it could be sustainably harvested to decimated kelp forest just in a short 40 years. I think the East Australia currents changed. There's been 3 or 4 degrees of global warming off of the waters off of eastern Tasmania, and 2 degrees here in my hometown of Woods Hole, and the global average is around 1.1 degrees. But this, in a sense, the kelp forest off to Tasmania is a picture of the future, because that's showing what's going to happen when we have several degrees of global warming. And quite frankly, it's not sustainable. We're seeing changes even at 2 degrees here in Woods Hole, where a lot of the sardines and minnows, menhaden, anchovies, the small fish, are being shifted with warmer waters to jellyfish, ctenophores, and gelatinous creatures. And so that's a bit of a dead end. I mean, there's some sea turtles that eat those, but really the larger fish tend not to eat them as much. And so it's a challenge, because these ecosystem shifts happen with just 1 or 2 degrees of temperature change. With barely over 1 degree of temperature rise on the Great Barrier Reef, we're seeing annual coral bleaching. And that's the sort of thing where, we've run systems where with marine permaculture, we could cool the mixed layer by 0.5 degree Celsius. That's enough to actually bring the corals back to health. And so that combination of sustainable harvesting and ecosystem services is something that's actually economically sustainable. And if we show that it can work at a hectare scale and above, then we could actually start scaling this to square kilometers and ultimately protect dozens of kilometers of coral reef. And with a sustainable economic model, we can then bring in private investment that could in fact support the ecosystem services that might be needed for most of the Great Barrier Reef. So that's our hope for the coming years, to do this in time and keep most of the reef alive.
I have one more question, and then I'll let you go, because you've been so generous with your time. Down in the Gippsland Lakes area, which is, I'm not sure if you're aware of where that is. So you've got Tasmania, then there's the Bass Strait, and then there's Victoria. And along the coast of Victoria, there's a 90-mile beach, and behind that is the largest inland lake system in the southern hemisphere. It's called the Gippsland Lakes. And I've spent every year I've been going down. I'm 50 now, and I've spent every year down there for at least a month of my life. And I've noticed over the years that it's completely changed. What happened, it used to be completely covered with seagrasses, a really strong fishing industry. When you go there now, there's a sandy bottom, there's no seaweed, and it's mostly filled with jellyfish. And I'm wondering whether you have any suggestions or ideas so it being mostly freshwater lakes, but there is a slight entrance, so it's slightly salty, whether marine permaculture is something that could be utilized in that context.
I think it can. I'm actually working right now with the Great Harbor Yacht Club in Nantucket to try to restore the seagrasses of Nantucket Harbor. This is something that's dropped in the last few years, and they have traditionally a commercial scallop fishery that they have used, and they have a scallop hatchery there, but the problem is the habitat's decreasing. If you go to a depth of greater than 5 feet, there's no more seagrass. And we asked the question why. Well, it turned out the water temperatures are going up, and there's a lot of runoff occurring from, let's say, lawns, and from some of the houses are on a septic system, so there's nitrogen getting into the water, and that combination of nitrogen and fertilizer runoff has resulted in eutrophication, or let's say high nutrient loading of the harbor waters itself, coupled with the high temperatures, results in a lot of microalgae and plankton growing, which cuts the visibility. And just as we were saying before, the juvenile kelps couldn't grow from 25 meters when the water was too murky. Similarly, the seagrasses can't grow if it's too dark. And if there's too much phytoplankton and microalgae in the water column above the seagrasses, they cannot grow. And so the challenge is to restore the environmental conditions that existed pre-industrially. And it's a combination of temperature sometimes, but also managing the nutrient levels and the circulation. And we find time and again that restoring circulation to these water bodies can restore their ecosystem function. And so we've been looking, because traditionally in Nantucket, they would cut between the ponds and the ocean twice a year. They would have to add a cut to enable the eels to swim out into the Sargasso Sea where they reproduce, and to enable some of the small forage fish to, they call it a herring run or something, to go back into the ponds. And so every spring and fall they did this, and they still do it to some extent. And it turns out that's something that occurred naturally, that there were these sand breaks that would occur, and during storms and whatnot, there would be these openings to the sea. And that was the key to these particular species to get across. And so the eels needed to get out and the fish needed to get in, and vice versa. And it turns out that that's a great way of ensuring circulation. And so we're considering for the harbor the possibility of actually restoring that circulation by having a sustainable access, perhaps even with the tides, where on an incoming tide, you could drive water from the ocean into the brackish ponds, if you will. And then on the falling tide, it would go out perhaps through the natural harbor channels. And this is something we're considering on a small scale for, well, it's about 15 or 20 kilometers of Nantucket Harbor, as one of several possible approaches to restoring circulation, getting the water temperatures back down to where they were pre-industrially, and getting the nutrient levels back down to where they were pre-industrially. And if you do that combination, we have good evidence that the seagrasses can come back and create healthy habitat for scallops and shellfish and all sorts of marine life. So I would look at scaling these kind of early tests that we're doing in Nantucket and elsewhere to larger system, and I would love to explore whether it could apply in Australia, and look at the geographic context and the historic temperatures and nutrient levels, and see what kind of sustainable solutions we could find there to restore the environmental conditions that are needed for these ecosystems to thrive.
Yeah, that would be fantastic. I'd love to work with you on that. That would be absolutely amazing. Now, I know that there's probably lots of questions, so when we finish up here, maybe if we could just stay online and we can do like a chat answer by typing, so if people can type in their questions, that would be fantastic. So just to finish off, just how do people find out more about marine permaculture, or if they would like to maybe get involved or support the work that you're doing, how could they do that?
They can go to our website, climatefoundation.org, and they can email us at info@climatefoundation.org. And also on our site, we're planning to do sort of a membership program where we can keep people in touch with a newsletter, be able to get people involved with projects around the world. And we have one project starting in Tasmania. We have more projects planned for around Australia that need support and funding and resources. So we're looking forward to trying to develop those. And then finally, we're looking to really build a grassroots movement to promote this around the world. And that includes tropical subsistence seaweed farms. It includes temperate marine permacultures, and even in the high latitudes, restoring the sea ice habitat that's essential for a lot of the Arctic creatures. And so we see the ability to really use marine permaculture principles the world over to really regenerate life in the ocean. And we look forward to working with all of you to ensure that this becomes the norm in the years to come.
Great. Well, thank you so much for joining me here on the Permaculture Education Institute Masterclass series. It's just been an absolute pleasure, and I look forward to talking with you more over the years as this continues to develop and to see it become more of the norm. Thanks so much,
Well,
Brian.
thank you, Morag. It's my pleasure.